In section 6.4, we're going to be discussing or talking about the division of polynomials. We've done a little bit of division with rational functions, but this fits nicely within this section because we're going to talk about how we simplify a division problem when we take a polynomial divided by another polynomial, another way of performing the rational operation, that is the fraction operation. This section, in some versions of college algebra textbooks, will actually be in the same section of polynomials when you first cover factoring, but we're going to go ahead and cover it in this section. The nice thing about dividing polynomials this way, using what we call long division, is that it's exactly the same algorithm, the same step-by-step procedure that you learned back in grade school when you were dividing large numbers. When you took something like 765 and divided it by 18. There's a technique that you used for long division to figure that out. And then you had the long division bar. You'll see it all here in a second. And then you had the remainder. And we're going to go through those steps. And it's exactly the same procedure when you throw polynomials in the mix instead of just working with numbers. Alright, so let's take a look at how we use division when we're taking a polynomial divided by a polynomial. In order to divide a polynomial by a monomial, we actually have a little bit simpler case to deal with. So let's look at that example first. Divide a polynomial by a monomial. All you have to do in that case is to divide each term of the polynomial by the monomial. Remember that monomial just means one term. So there will not be any additions or subtractions in the denominator if we're going to be dividing a polynomial by a monomial. So look at this one right here. We take the example where we have 40x to the fourth y cubed minus 20x cubed y squared minus 50x squared y. All of that divided by 10x cubed y cubed. So what you want to do first is just express this division, the old style division problem, as a fraction. So write it first in fraction format. And once you do that, just split this up into three different fractions. That is, you're going to divide each term of the polynomial by the monomial. I'm going to take 40x cubed and write that over 10x cubed y cubed. Sorry, 40x to the fourth y cubed. Write that over 10x cubed y cubed. Then I'm going to do the same thing for the second term, and then I'm going to do the same thing for the third term. And what I end up with is this. I'll have 40x to the fourth y cubed divided by 10x cubed y cubed minus 20x cubed y squared divided by 10x cubed y cubed minus 50x squared y divided by 10x cubed y cubed. And really all we're doing is the rule for adding fractions, but in reverse. You'll remember that if you were to be asked how do you add 1/5 plus 2/5, right? Way back in grade school, you know all you had to do is add the numerators. You're going to have 1 plus 2 over 5. Well, notice what I just did is the reverse of that principle, right? That is, if I can add the numerators together and keep the same denominator, if I have only one term in the denominator, I can go the other direction as well. Now, once I get to this point, all I'm going to do is to reduce each fraction as much as I can. For example, 40 and 10 have a common factor of 4. Right? I can take an x cubed out of the top and bottom, and I'll be left with x to the first on top. And I can take the y cubes out of both top and bottom. I'm left with 4x to the first. Minus. Notice how the signs, by the way, just stayed the same as they were in the numerator. Now take 20x cubed y squared divided by 10x cubed y cubed. You can take a 10 out of the numerator and the denominator. You're left with 2 on top. The x cubes completely divide out. I can take a y squared out of top and bottom. I'm left with a y to the first on bottom, so I have minus 2 over y. Alright, now we have minus. We can take a 10 out of both of these, and we're left with 5. 5. We can take an x squared out of top and bottom. I'm left with x to the first, and a y out of top and bottom. I'm left with y squared. So on bottom, I have a x to the first and a y squared, and that is completely simplified. Okay, so we just had to simplify each question. By the way, for that small interruption there, I apologize. My recording sometimes takes place at home, so you'll get to hear maybe a couple of my kids jump in there. Let's do one more just so you can see another example worked out. If we have 16x cubed minus 32x squared plus 2x plus 4, I can first convert this into a fraction, right? Write it as 16x cubed minus 32x squared plus 2x plus 4, all of this over 4x, and then write each one term in the numerator over the denominator term. So 16x cubed divided by 4x minus 32x squared divided by 4x plus 2x over 4x plus 4 over 4x, and then simplify each fraction. Pull 4 out of the numerator and denominator. Well, with 4, x comes out leaving x squared, so 4x squared is my first term. My second term now will be minus, and 4 goes into 32 8 times. X goes into x squared, x to the first time, so minus 8 x to the first. The x's completely divide out, but the 2 goes into the 4 twice, so I have plus 1/2. Here the 4's divide out, I'll have plus 1 over x. Don't forget that whenever everything divides out from a numerator or from a denominator, you're left with a 1. And in the case that the denominator completely was gone, instead of writing it over 1, I can just write it as itself, because anything divided by 1 is itself. Okay? Alright, the other thing that we're going to be doing in this section is dividing in the rest of the cases. We know what to do when we're dividing a polynomial by a monomial. What if we want to divide a polynomial by a polynomial? And the nice thing about it is we can use a technique, I should say, that is very similar, if not identical, to the technique that we used whenever we learned how to divide numbers. So we're going to be doing what we used to do with numbers with equations now. So just as a refresher, what do we do with numbers? If I had to divide 624 divided by 4, okay, instead of pulling out my calculator right away, I can do this calculation by hand when necessary by just writing 624, putting it under this little long division symbol, and put the divisor 4 on the outside. And you'll remember again from your grade school days how we learned to divide this, right? You put a 1 here because 4 goes into 6 one time, then you multiply 1 times 4 and you write it down beneath the 6, you subtract, and you have 2. Right? 6 minus 4 is 2. Then you bring down the next number, which is a 2, and you ask the question all over again, starting from the beginning. Well, how many times does 4 go into 22? And the answer is, well, it doesn't exactly, but the closest I can get from underneath, that is the largest number that is less than 22 that 4 goes into is 20, so I can put a 5 up here. 5 times 4 is 20. Subtract. I'm going to be left with 2. Now I bring down the 4. And 4 goes into 24 6 times. 6 times 4 is 24. And I have a 0 remainder, so my answer is 156. This technique can be adapted to handle polynomials as well. Let me start by doing a quick example, and then we'll write out step by step what we're doing throughout this process. Now, in order to divide, in this case, 4x plus 7 by x plus 2, I'm going to start by putting the dividend underneath the long division symbol, the dividend being that first number in a division problem. The divisor is going to sit on the outside, the thing that I am dividing by. And in each case, I want to look at the leading terms of those two polynomials. And I'm going to ask, okay, what do I have to multiply the divisor by to get to the dividend? In this case, I have to multiply by the number 4, right? To get from x to 4x, I've got to multiply by 4. Now, 4 is a constant, so I'm going to write it above the constant term here, 7. I'm going to write a 4 right there. Now I'm going to take the 4 and I'm going to multiply it times the divisor. Now when you multiply 4 times the whole divisor, you're going to have to distribute. So you take 4 times x, you get 4x. When you take 4 times 2, you get plus 8. Right? So, same process as before, we're just happening to look at the first term in each case, in each the divisor and the dividend. What do I have to multiply x by to get to 4x? The answer is 4. Now take that 4 times the divisor. Now you're going to subtract. Okay, now when you subtract, you actually have to subtract both pieces, which means change the sign and combine. So 4x minus 4x is 0. They cancel out. 7 minus 8 is negative 1. And so we have that 4x plus 7 divided by x plus 2 is 4 with a remainder of negative 1, which in general the way that I will write that is to write the remainder over the divisor. I think in one class along the way you probably learned to put an R on the outside of a problem like we looked at previously. You might, if you've had a remainder down here, you might have written 156 with a remainder of whatever number we got. In our case we got 0, but if you had a remainder of 1 you might put that there. Now in the case where you have a remainder, you might also be able to do something like whatever the remainder is. Say it's if it had been a 1, you'd put 1 over whatever the divisor was, a 4. This was if the remainder had been 1. In our case, we didn't have to do that, but that's just a side case. Okay? So that's what we did down here in this example that you see right there. Okay? So let's look at then the step-by-step procedure that I just went through by looking at this example here. Take and divide x cubed plus 3 or 5x squared plus 7x plus 2 divided by x plus 2. Okay? Now the first thing you need to do before you do anything else is you've got to arrange the terms of the dividend and the divisor in descending order. Now descending order just means that the powers go from the highest power down to the lowest power. Okay? The second thing you now do is divide the highest term, that is the leading term on the inside of the dividend, by the leading term of the divisor. Okay? So x cubed divided by x is x squared. Right? That's what I have to multiply x by to get to x cubed. Okay? And then align the term. So I'm going to put the x squared that I just got when I divided above the 5x squared. Now you multiply each term in the divisor, which is x plus 2 here, by x squared. So x squared times x is going to give me x cubed. X squared times 2 is going to give me plus 2x squared. All right, now you subtract the x cubed plus 2x squared from the x cubed plus 5x squared by changing the sign of each term in the lower expression and then adding. Right? If I want to subtract this whole thing, I've got to distribute my minus sign to each one. So I change the sign of everything in there, and then I combine. X cubed minus x cubed subtracts out. 5x squared minus 2x squared is a 3x squared. Okay? Next thing you do is you bring down the next term. In our case is 7x. Bring the sign with it, so plus 7x. Okay? And add algebraically to form the new dividend. Now find the second term of the quotient. That is, we're going to now find the next part of the answer. We're going to divide the first term of 3x squared, which is right here. Sorry, 3x squared plus 7x. We divide the first term of it, 3x squared, by x. 3x squared divided by x is a plus 3x. 3x, now we're going to multiply that 3x times the divisor again. Again, aligning the terms under the new dividend. So 3x times x, 3x squared. 3x times 2 is plus 6x. Okay, then subtract. Actually, I was skipping ahead here. Next thing we do is subtract. Minus 3x squared, subtract out. 7x minus 6x is just 1x. Bring down the 2. Divide x by x. We're going to get plus 1. 1 times x plus 2 is x plus 2. Change the signs, and you get 0. So I went a little bit fast here, but you bring down the 2. Find the third term of the quotient, which is 1. Multiply the first term of x plus 2 by the 1. Sorry, I actually got the wrong thing there. Divide, I apologize, let's do this again. Divide the first term of x plus 2 by x, we get 1. then multiply the divisor. That's where I took the 1 times the x plus 2 and wrote it down here. Then subtract and obtain the remainder of 0. Okay, so again, the steps are basically this right here, and you just start over after you've done that. You arrange, you divide, multiply, subtract, and bring down. Then you divide, you multiply, you subtract, and you bring down. All the way through. You go through that till you get all the way down to a number that is the remainder. So here are these steps written down one more time. To divide a polynomial using long division, here's what we're going to do. Arrange the terms. Let's do this in blue to be consistent. Arrange the terms of both the dividend and the divisor into descending powers of any variable. Okay, next thing you do is you divide the first term of the dividend by the first term of the divisor, and the result is the first term of the answer, or the quotient. Then we multiply every term that's in the divisor, that's outside the long division symbol, by the first term of the quotient, which is the answer. And we write that resulting product of the dividend underneath the dividend where the like terms line up. Then we subtract the product from the dividend, which means basically change the signs and add. Change all the signs. Now, once we get to that point, we're ready to start over. So we bring down the next term from the original dividend, write it next to the remainder to form a new dividend. Use this new expression as the dividend and repeat the whole process from the beginning. And you keep going until the remainder can no longer be divided. This will occur when the degree of the remainder, that is the highest exponent in the remainder, is less than the degree of the divisor. So if I had an x term on the outside, then the remainder would be whenever I get to something without an x. If I had an x squared on the outside, the remainder would be when I get down to something that's an x term. X cubed on the outside, the remainder would be when I get down to something that's an x squared in the remainder, and so forth. Okay? So let's do one more example for us here. Oh, jumped a little bit ahead there. Let's work this one out. So start by writing your dividend underneath your long division symbol. Let's write it in descending order. So we have 3x to the 5th. What's the x to the 4th term? Well, there's not one, right? We got to go 5, 4, 3, 2, 1, 0. If there's no fourth degree term, go ahead and write one in there. Just write it with a 0 coefficient. So it's still the same polynomial, but now we've got a place to line up our x to the 4ths. Okay, so plus 4x squared, how about minus x cubed plus 4x squared minus 12x minus 8 with an x squared minus 2 on the outside. So we need a place to line up the x to the 4ths in general, so we're going to put every power from the highest down to the lowest, and if there's a missing term, just stick a 0 coefficient there and it'll work. So now take 3x to the 5th divided by x squared. That's going to give me a 3 and an x cubed, so I'm going to write it above the x cubed. 3x cubed times x squared is 3x to the 5th. 3x cubed minus 2 times a minus 2 is minus 6x cubed, so it goes right here because we line up like terms. Now to subtract, we go in and change our signs. That drops out. That drops out. Minus x cubed plus 6x cubed is a plus 5x cubed. You don't actually have to write the plus. It's understood. So let's get that 5. All right, bring down the next term, 4x squared. And since we canceled 2 powers at the same time, we're going to bring down the next one as well. Now I look at x squared and 5x cubed. Let's divide 5x cubed by x squared. That's going to give me a plus 5x. Multiply 5x times each term in the divisor. I get 5x cubed minus 10x. I'm remembering to make sure that I line up my like terms so that when I subtract, everything combines with like terms. So 5x cubed minus 5x cubed gone. 4x squared plus 0 is 4x squared. Minus 12x plus 10 is minus 2x. Bring down the minus 8. 4x squared divided by x squared is plus 4. So 4 times x squared is 4x squared. 0 and then minus 8. So change my signs. Combine. Those subtract out. So I have minus, and then I put 2x. I put a minus here because of the minus that's down here. Minus 2x over x squared minus 2. This is my answer. 3x cubed plus 5x plus 4 minus 2x over x squared minus 2. Okay? Or written more condensed, 3x cubed plus 5x plus 4 minus a 2x over x squared minus 2. There we go. And that's how we do long division with polynomials. That's the end of section 6.4.